All right, welcome back to the deep dive. Today, you've sent us a really specific piece of hardware. It's the PureLink OLC DVI to 2LC fiber transmitter. Now, on the surface, that just sounds like a component, right? But when you dig in, it's really an insurance policy for mission-critical video.
It absolutely is.
So our mission today is to quickly unpack what makes this one little box so important, especially for these high-stakes professional AV setups. We're going to look past the spec sheet and into its DVI 1.0 compliant core.
Exactly, because we're talking about a really fundamental problem. How do you maintain a perfect high-res digital signal, and this is DVI-D, so digital only, when your source and your screen are, miles apart?
Yeah, your standard copper cable just isn't going to cut it.
Not even close.
Okay, so let's start there with those performance boundaries.
Yeah.
The most striking number here has to be the distance.
Mm-hmm.
I mean, we're talking about pushing a full HD 1080p signal up to 6,600 feet. That's 2 kilometers.
That's amazing.
To put that in perspective for you, that's nearly a mile and a quarter. You could connect buildings across a massive corporate or university campus.
And what's fascinating here is how it does that. It's the fiber itself, that huge 6,600-foot number that's using single-mode fiber, which is built for these incredibly long hauls.
Right. And what about multi-mode?
Even with multi-mode fiber, which you see more often in, say, a single building, you're still getting a massive 650 feet.
And the key is, in both cases, you're not sacrificing resolution. It holds that 1920 by 1260 frames a second signal perfectly.
Perfectly, but, getting that distance is really only half the story.
Because with sensitive data, security becomes the main issue.
Exactly. Fiber optic cable, unlike copper, it doesn't leak electromagnetic signals. That means it's pretty much immune to outside interference, and more importantly, it's incredibly difficult to eavesdrop on.
And that right there, that's the so what for the target markets, isn't it?
Yeah.
Government, military, medical applications.
Yes.
If you're dealing with classified information or, say, real-time patient data, that kind of signal security isn't just a nice to have. It's absolutely mandatory.
Right. It's a core requirement.
Now, beyond security, PureLink built in a feature that just seems to solve a huge installation headache. They call it auto ED programming and virtual DDC.
Yeah, that's a big one.
So for anyone listening, what exactly is DDC?
It's basically the digital handshake. It's how the source, like a computer, and the display talk to each other to figure out the best resolution to use. And before this, you often needed a whole separate wire just for that handshake. With this, the PureLink transmitter handles that negotiation virtually over the main fiber link. It just simplifies everything.
That sounds like a huge time saver in the control room.
Right.
But doesn't fiber itself come with other headaches? I mean, like running and terminating the cable?
That's a fair question, and they did think about that. The design is really practical. The transmitter and receiver modules are actually detachable.
Oh, I see.
So the integrator can run the thin fiber cable through tight conduits and walls and then just clip the modules on at the end. The unit's tiny too, only 1.5 inches wide, because rack space is always at a premium.
So before we wrap, let's just hit the fine print. We've got a single link male DVI-D input, and it uses 2 female LC fiber outputs. The price is listed at $759, and it's got a 3-year limited warranty.
And it's TAA compliant, which is important for government contracts.
Right.
But when you're investing this kind of money, I think you need to look at one more number, the MTBF.
The mean time between failures.
Yes, and this unit is rated for 50,000 hours. That is a serious, serious reliability metric.
So when you put it all together, from the virtual DDC simplifying that installation to the inherent security of fiber, this isn't just a component. It's a full-on, high-security, long-distance video solution.
It is, and it raises a really interesting final thought for you to consider. 50,000 hours. That means this system is designed to run non-stop for almost 6 straight years. Wow. And it can do that in temperatures from freezing all the way up to 117 degrees Fahrenheit. So the question is, what are the broader implications of needing video infrastructure that reliable? What systems in your life should be held to that same 6-year fail-safe standard?